Hello, everyone, and welcome to the Tom's Hardware Podcast for June 15th, 2021. As always, I'm Tom's Hardware Editor-in-Chief, Avram Pilch, and we are joined by Raspberry Pi expert Ash Puckett, Tom's Hardware Associate Editor Les Condor, and today's very special guest, Ravi Butani, who has created what is probably the world's first Pico-powered drone. Wow, look at that.
That's so cool.
That is,
all those configurations are fantastic.
That is really cool. So Ravi, can you tell us about your project and what got you started with it and where it stands now?
Actually, before a month or so, I get to know that Raspberry Pi Pico board is launched, and this is something new from the Raspberry Pi Foundation, having a microcontroller. So this is a good time to test this for a flying platform. Earlier, I have already made a drone project for Espressif. At that time, I have made ESP32 based drone, which is controlled by mobile application using Wi-Fi. So this time I thought that because Raspberry Pi is very famous for educational purpose, let's do something that can be used for educational purpose in STEM or STEAM-based education. And as you know that aero modeling is a very popular hobby, but the entry barrier in terms of a cost is very high for this hobby. So I thought, let me develop something that will support all the flying configuration. Kids can play with it. Kids can learn from it something. Kids can easily break it, assemble it, and fly it, move it, whatsoever. So for that, I have initially made the drone based on this prototype board, which is here. This is the first version. And after successful flight of the quadcopter, I moved towards this board. It has MPU 6050 on board. The board supports 6 DC motors, coreless DC motor, and 4 servo motors. So I think 6 motor and 4 servo motor is enough to make many configurations in terms of ground vehicle, or it may be flying drones, multicopter in terms of tricopter, quadcopter, bicopter, hexacopter. Even many configuration of the fixed wing airplane can be also designed using this platform. So the thing is, main thing is firmware. First, I have developed the firmware on RP2040 SDK, and just recently I get to know that Arduino is also having a port for RP2040. So quickly I moved towards Arduino because for kids, who is the main user, Arduino is a better programming platform. So for STEM-based education, there are many drones we see, but the thing is, all the hardware, lots of sensors are there, but the kids finally can move the drone 10 centimeter left, 10 centimeter right, forward, reverse. So it's not STEM education basically. STEM education means the kids should learn basic principle of science, engineering, technology, and mathematics used in the drone. So for that, the key thing is I have developed many sample codes. So these sample codes are actually building blocks. So instead of using a ready-made firmware, the kids can use this building block to make their own firmware. Means they can easily modify the firmware of quadcopter to control the fixed wing plane.
So you're doing that in Arduino? You're using
right now,
Arduino IDE?
Yes, both are supported. SDK is also supported, and Arduino is also supported. Arduino is cool actually. There are many possibilities open with the Arduino. I have to invent something in the Arduino itself to make it compatible for this drone. Means I have make many modes in the Arduino IDE itself to use it with the drone. Instead of PIO, means I have write many small program for RP2040 PIO for drone application.
Right. That makes sense. So, is this a board you're going to be selling?
Not yet. I want to make this entire project open source. But the key point is once the board is ready, something is ready to put in the palm of the kids, then there is the actual meaning of the open source software and open source hardware itself. So because right now, as you can see, this board looks tiny, but for the tiny drone, it's bigger. Its weight around 14 gram, and it is sandwiched between two boards, Raspberry Pi Pico itself and one sensor and control board. So what I want to do, I just want to merge these two boards, and for controlling, mobile application is also supported for low range control in indoor environment or in garden or park. But for a longer range, this kind of RC radio is also supported.
So what type of wireless does it use?
Yeah. For wireless communication, this is ESP01. I am using my custom firmware on that, which will mimic the iBus protocol, which is very standard for radio control. So I just need to remove this ESP01, and I can simply plug this iBus receiver.
Right.
Yeah. So it can be controlled from this radio instead of the mobile application. So this is just plug and play. It doesn't need to change any firmware.
That's really cool. That's clever.
Oh, that's really neat. So what type of power source are you using for it?
Actually, I have for the power management, Raspberry Pi Pico board itself having a boost converter, which is very useful for this project because I am using a 3.7 volt LiPo battery. And if I want to convert 3.3 volt from 3.7 volt battery, then dropout voltage is a key point. Means
Right.
When the drone is flying, actually all four motors are sucking the current from the battery. So at that time, the voltage sometimes drop below 3.5 volt, but still the battery was used.
Right.
So rather than making the thing complex, what I have done is I have directly used this boost converter on the Raspberry Pi Pico itself, and one GPIO is there on the Raspberry Pi Pico connected to this boost converter to use it in high efficiency mode. So I have in a programming also, I have make sure that the boost converter will provide enough current for Raspberry Pi Pico itself, sensors, as well as ESP or RC receiver, whatsoever connected on the board.
Wow, neat. So how far have you been? How many propellers are you using on your drones, and how high can they fly?
It based on the configuration of the drone. This is the quadcopter, so basically there are 4 propeller. I am using 65 mm diameter propeller here, which is a standard for this 820 coreless DC motor. It is 8 millimeter in diameter and 20 millimeter in length. The motor RPM is 40,000 RPM at 3.7 volt, and the thrust produced by the motor is 35 gram maximum for each motor. So actually, rather than using the brushless DC motor, I have choose a brush DC motor to reduce the cost, as well as I don't want more weight, because in India, based on the weight, the drone is having a category, and for that, a user need to get a license. So I need to make sure that whatever I am doing, it doesn't require a licensing procedure. In terms of height, there is no barrier. I think 50-60 meter I have flown this drone. The problem is after 100 meter or so, you will lose the visibility. Means the orientation of the drone can't be visualized. So 30-40 meter is good enough for this kind of micro drone. And if we are using the same board on fixed wing plane, which is something bigger in size because the body is made from foam, we can go up to 200-300 meter because the orientation is not get loose from the site. That is the key point here for the small flying vehicle. The range is not a big deal. Wi-Fi will give 100 to 150 meter range in line of sight, and this RC radio, beginner's RC radio, will give the range up to 1 kilometer. So that is not a big problem.
Wow, that is a lot of space. So when you are you primarily looking at it as program it to use manual controls, or are you also able to program it to act independently?
Means the kind of autonomous application, right?
Yeah.
Currently, the drone is having 6 DOF IMU and barometer. So the attitude is stabilized and altitude can be stabilized. But to make it autonomous, I need to use the sensor which is normally come in a mouse. In indoor environment, I can do it autonomously. But yet I am testing it. I have not completed this part.
Great. So can you actually fly some of them for us now? Is that possible in your current location?
Yeah, just a few seconds. I am going to make a setup, but before that, I will show the mobile application.
Oh, great.
Which one you would like to fly? 3, 4, 6 blade?
I think. What do you say? Les says 6. Ash says 6. I guess you want the.
I'm going
full,
to set up
the full 6.
This is the
That is
mobile app.
pretty.
Very nice.
Yeah.
Yeah, that is a nice interface. That makes
this
a
is the
difference.
controller. Yeah, controller screen. The controller screen support left-handed people as well as right-handed people, so the joystick can be swept easily. Low rate mode and high rate modes are there. So based on the rate, beginners or expert pilot can use the same application. And signal strength in dBm and battery voltage is also showing. Flight timer is there on the screen, as well as there are 4 auxiliary channels. So a user can configure any GPI, remaining GPI of the Raspberry Pi Pico to attach some payload kind of thing. Just trigger it.
Great.
Yeah, that's considerate.
Yeah, and the same application is used to modify the PID settings. Because using the same flight controller, there are multiple flying configurations are possible. So every time user need to change this PID setting. So it can be also done using the same application. So I'm going to set up the drone within few seconds. Meanwhile, you can carry on.
Okay. All right. We'll talk amongst ourselves. So
Madhuri?
Anyway, that is really, really cool. Here, I'll just toss him off for a second until he's ready. That looks really cool. I have not seen any Raspberry Pi drones before. Have you?
I've seen a Pi drone, but not a Pico.
Yeah. It's the first Pico one that I've seen. That's why it intrigued me to have Ravi on the show.
Yeah.
And it's configurations as well, from 3 to 4 to 6. And then it can be a boat that's just controlled by the blades moving it across the water, or it can be flying around like a plane as well.
So that point, the modularity of it, just in general, is really cool. That he wants it to be something kids could use. That you can attach anything to the GPIO and add, make any kind of drones add-on that you want. That's awesome.
Yeah.
All right. Let's see if he's ready. Hey, you ready?
Oh, he's muted.
All right.
Here we go.
All right. Let's see how this looks. Wow, that looks fantastic.
That is so cool.
Really nice. I love the simplicity as well.
So now it's ready to fly.
Wow, look at it go.
I love the lights. Oh.
Nice.
Oh, very nice. Oh, that's fantastic.
That is super cool.
That is very stable.
Yes.
Yeah, that's like better than any drone I've ever flown. Mine usually fly into the wall and are broken within about 5 minutes.
Yeah, kudos to the pilot on that one.
Yes, yes. My son keeps asking me for drones. Every time I get him one, it breaks almost immediately. So I've stopped.
Actually, my reflexes are not good. I'm not a good pilot. I'm good maker, but not good pilot.
Oh, wow, that is fantastic. That looks great. That is really, I mean, now can you make it stand still? Or can it hover in place?
Right now, there is no sensor to lock the position. So continuously need to do a little correction.
Got it. Wow. What kind of battery life are you getting on it?
For this X-copter, I am getting 5.5 minutes. For quadcopter, it's 7.5. And for tricopter, it's 9 minutes almost.
That's not bad at all.
Yeah, not bad, all things considered. And I mean,
so can I land it?
Yeah. Oh, great job.
Nice.
Well done.
That is fantastic. Wow. So I would love to try that. If somebody wants to actually try this at home, what is the best way for them to get started?
Just a minute. I am going to make the setup.
Yeah, of course.
I bet if you were to get something like this for Isaac, Avram, that he might be more inclined to pilot it carefully before crashing it.
Nothing will make him inclined to pilot it carefully.
Now
he'll try. I mean, don't get me wrong.
Yeah.
But
I mean, piloting drones is hard at first.
But listen, the experience of building it is a reward unto itself, I think.
Yep.
Definitely.
So if someone wants to build that at home, what do you have all the instructions out on the internet for people to see?
This is the main thing for the STEM or STEM education. You need to continuously provide the build instruction for the multiple flying models. So currently I'm going to make the build instruction for this 3 configuration. And as you can see, this is also in loop. First, I'm going to convert this very low cost foam model glider into the RC1 using the same book. So this is the next project on the same platform. And for the build, actually, to reduce the cost, I'm using this sketch pen as the arm of the drone.
I thought it was something like that. I just couldn't quite tell. That is a really good idea.
It costs 5 cents for 15 sketch pens.
Nice.
Bargain.
The cap is work as a motor mount, and the sketch pen itself work as an arm. So it's like this.
So I know you have some videos that folks can see if they want to learn more, and the place to go would be to search for Ravi Butani 03 at YouTube, correct? And we put it up in the banner there, and you can see videos about how this is made. But eventually, you're going to release the designs on GitHub or something like that.
Sure. My first plan is come up with final hardware in the market. I am also in communication with some STEM kit manufacturers. If they are agree, then with their logo they can sell it. I will provide the software support whatsoever needed, and in every week or every fortnight, the new model build instructions will make available online. So everybody will get engaged. Whosoever have this plan.
Wow, fantastic. That looks like so much fun. Speaking of things that are so much fun, Les, you've been playing with another new toy, which is the Trinky, right?
Yeah, it's a Trinky board from Adafruit, and I particularly like these little boards. They don't serve an actual use as such in my life just yet, but they're slowly working their way into little things I want to build. And I'm going to show you an overhead camera now what it all looks like. So just here is... it's done it again. It's crashed again. There we go. Let's go back to this one. Okay. So there is Adafruit's Trinky RP2040 QT. Let's do the YouTube trick and put a hand behind it. There we go. And as you can see, it's a USB-A port and an RP2040 in the middle. And there's no GPIO on it. Now, right now, you're thinking it's a bit useless, isn't it? No GPIO. But it's got a stemmer QT connection just on the back here, and two simple imports. One is a reset button, one is a boot select button, which also has another function, the user programmable button. There's a NeoPixel, and if you just need a bit of electronics connection to build some sensors and do some quick work, so we're going to do some temperature sensing or look at light patterns or control simple things, you can plug this straight into your laptop or your desktop, and you've got the RP2040 ready to go. Now, I mentioned it's got a stemmer QT connection, and I've got a few stemmer boards here. So I'm cheating and reading from the back. This is an AS7341 I2C 10-channel spectrometer. So it looks at colours and measures the amount of colour in light, I should say. And I've got a BME 688. This is one of Pimaroni's. Let's get you in. The curse of the live demo, this, isn't it? No, don't want to focus.
It's fine. We'll take your word that it's that. So what type of sensor is that?
That is a temperature sensor and humidity sensor, and also it's a gas sensor as well. Which gas it measures, I don't know. And I don't want to find out either. Not just yet. So I'm going to plug this into the board using stemmer QT. There you go. So I've got two sensors plugged into this board now. This would all be really slick if my overhead camera would work. Oh, there you go. You can see it more now. Lovely.
Very nice.
I'm going to plug this into my USB hub. And there's some code already running on this. Well, there will be in a second. There we go. Just starting the code. So this is the Mu editor. We had Nicholas Holloway on the show a few weeks back. This is his editor for writing MicroPython, CircuitPython, all sorts of different Pythons. And I'm using it to just do some CircuitPython code to get the current temperature, which is 27.4 degrees C, and humidity 54.7%. And also it's looking at how much color is in the light that it can see. So I've got an overhead light on right now. If I was to turn this light off and turn this one off, we will see the values change when it goes round each time. So it's getting live updates as to what it can see. And this is all connected via I2C stemmer QT connection directly into this board, which is plugged into my desktop computer. So you are probably thinking, no, it's got no GPIO. How much is it? It's $7.50 for this. And the nearest rival to it is Adafruit's own. Let's get the right shot in so you can see me. That's always good. There it is. And you've got the Qt Py, which is about the same price. So this has got GPIO and it's a slightly smaller form factor. But you've got trailing wires with the Qt Py. You've got the USB lead. This just plugs straight into anything that's got a USB-A port. You can write your code and away you go. So I'm doing a review on this for this week. And it should be out at the weekend.
Oh, that's exciting.
Yeah, there's no shortage of RP2040 boards. I want to mention that Les recently put up on our site, and we'll keep updating it, our list of best RP2040 boards. So there just keep being more and more and more. It's hard to collect them all. I have like 10 of them right here. Here's the Arduino one. Here's over here trapped under some wires is the Feather RP2040, my personal favorite still. And
now you can buy the RP2040 individually, right?
Yes, now you can just buy the chip. So yeah. I'm just going to buy a bunch and like festoon my clothing with them for no reason.
Now imagine that single chip, the RP2040, on Ravi's board. He could shrink that board even more.
Be a lot lighter.
Yeah, are you looking into doing that?
Yes, absolutely.
Cool.
That makes a lot.
I got the samples also.
Brilliant.
Ah, fantastic. So, speaking of new things to try, Ash, you were trying a completely new operating system this week, correct?
Yeah, let's take a break from microcontrollers. I want to talk about a new operating system that you can try on your Raspberry Pi. Well, I say new, but I should say something different from the standard Raspberry Pi OS. So I'm going to switch my screen over really quick and tell you guys about RISC OS. This is a screenshot from their website. This isn't my screen, because trying to figure out how to get it to run on a Pi and stream to you guys live has proven to be a little bit tricky. So I've just got some pictures to share to show you what it is. So RISC OS, what is it? It is an operating system that is designed specifically for ARM devices. It was designed in Cambridge, England by Acorn and released in 1987. So it's actually been around for a while. And it sort of fell out of popularity for a while until the Raspberry Pi picked up back in 2012. So there's a little bit more that you can do with it these days. So why would you want to use it in the first place? It can do almost anything that a standard operating system can. It has a GUI, as you can see. I think it looks kind of like, reminds me of like using Windows in the 90s, because it's very boxy and gray.
Windows 95, it looks like.
I like that, though. I kind of...
Or maybe Windows 3.1.
So, if you're a fan of retro PC stuff, you might want to take a look at it. There's all kinds of apps available that people have developed for it, because it's open source. You can do word processing, edit photos, and of course you can use stuff like Python to write your own scripts. One benefit is that it's not a very large operating system, so it's not going to use up a lot of space, and it's designed just for ARM processors, so it's definitely optimized for working on something like the Pi. And it works on the Raspberry Pi Zero all the way up to the Raspberry Pi 4, and they even have an image for it just for the Raspberry Pi 400. So I thought that was pretty unique that they had set aside something for the 400. Overall, it's just a neat option, I think, for Raspberry Pi fans who want to try something different. And if you want to get it, you can, let me hide this here. You can go to RISC OS. I'm sorry, let me find the website. Yeah, riscosopen.org. And RISC is spelled RISC instead of RISK. And if you go to downloads, you'll see all kinds of different options, platforms it's available for. And of course, there's one just for the Raspberry Pi. And putting it on the Pi is as easy as installing your standard Raspberry Pi OS. It works with the Raspberry Pi Imager. You just download the image from the website. There's a separate one, like I said earlier, for the Pi 400. You can format your micro SD card, flash it with Raspberry Pi Imager, and get started with running RISC OS. So what do you guys think? Have you heard of it before? Have you ever seen it used on a Pi before?
I have heard of it, but not seen it used on a Pi before.
Yeah, we had RISC computers in school when I was a teenager. Acorn Archimedes.
That's cool.
Yeah, it seems like, I mean, I'm not going to pretend to know enough about RISC to make it coherent commentary, but we know that RISC-V chips are becoming a thing now. I don't think they run this OS because they're more we've seen it in microcontrollers, and I think we're starting to see them try to go and compete with ARM. So yeah, I think we're going to see more RISC. I guess most folks know RISC stands for reduced instruction set computing, right? So
risky business.
So, as opposed to regular, which is CISC, I guess, complete instruction set. So speaking of instructions, one thing we've covered before here is image recognition and machine learning. But this week I tried something that it makes it really easy, which is using Microsoft's Lobe tool. So I'm going to share a screen on my PC, and you'll see how this works. So here's Lobe, and it has like three ways to use it. I mean, 3 steps, right? So you take images and you import them, which they could be directly from the camera on your computer. It could be image files from a phone that you took pictures with, or camera, or an existing data set. You take them in and you label them. So I've created 3 labels here: Raspberry Pi, 4, Rollerbot, which is my son's little Lego robot, and screwdriver. And they say that you should always have one for nothing, which is, I guess, where you don't see it. So you can test this on your PC. I'm using this on a Windows PC, but then you can take and, so then you hit train and it goes through and it like does a little bit of a processing. Right. So my camera on my PC is not working because I'm using it for this video, but here I have the ability to export it, and you export it as TensorFlow Lite. then you can take that file that you've exported and you can copy it over to a Raspberry Pi, and Adafruit has some wonderful instructions on how to use it with your Braincraft hat. So here I have, oh, my wire not long enough, of course. So here I have the Braincraft hat on my Raspberry Pi, and I also have a camera connected to it, and it will tell me what it thinks it sees. So if I zoom in for a sec, so right now it should say nothing because it didn't see anything interesting, right? But if I take a screwdriver and I put the screwdriver under it on my desk, will it say screwdriver? Well, it hasn't seen this screwdriver before, I must admit. It's seen other ones. So it worked fairly well, I should note, and it will only work better depending on how you train it. So admittedly, when I've trained it to do something in one environment and I move it to another, it hasn't worked super well. So like if I have it look at like something on my desk and then I hold it up in the air and like, you know, the same object, it's a little confused and sometimes says nothing or whatever. So, you know, like a lot of these image recognition things that sort of can be hit or miss. It probably gets better the more circumstances and pictures. And as you're viewing it on your PC, you have the chance to actually say, this was a correct recognition or an incorrect recognition, so you can train it further as you demo it, which is nice. I found this a lot easier to set up than a lot of the other solutions out there because it only took a few minutes to create the model, and then installing the software from Adafruit was like a few seconds. I mean, installing the hat, the Braincraft hat itself, you know, was a couple of scripts to run that may have taken 5 minutes. Now, let's say you don't have a Braincraft hat. That's okay, because this is all Python. So the goal is obviously not to just create a demo where you're just going to show whether it works on this little screen, but hey, can I make it do something? And they have some demos on Adafruit's Learn site about how to do a rock, paper, scissors game and other things with it. I'm curious, what would you all like to do with image recognition on a Pi?
I want to identify my cats and have specific things happen when a specific cat walks by. Some of them are more well behaved than others.
I see. Ravi, what would you do if you could add image recognition to your drone?
I would like to identify the things which is nearer around the drone. Means few color blocks are there, few shapes are there. So it should identify those stuff, and also it should be capable to navigate its way through the obstacle and also collect the information of the obstacles. Means what obstacles are in the way using the recognizer.
If you could merge that with autonomy, you could have it follow specific people or specific things or an animal.
Yeah.
Yeah. Now, I don't know if Lobe is good enough. Lobe is in beta now. I don't know if Lobe is good enough to identify an individual person versus just people, or an individual cat versus just a cat. But it would be cool. It would be cool to do, right? I mean, we know we certainly can do that with OpenCV.
Yeah.
So, Les, how about you? What would you want to add image recognition to?
This is an idea that a friend of mine, Simon Walters, had a few years ago for a truck, like something that carries along all your equipment for an event that just follows you along. So as you're walking along to the venue, this little thing's got batteries, it's got wheels, it's got motors, and it just follows you all the way along. And it's focused intently on you, but also looking around to see what hazards are about. And it just delivers your goods to the venue that you're at. Because when we all go to these technology events, like Raspberry Jamborees and Jams, that sort of thing, we're always carrying at least 4 or 5 Raspberry Pis, plus all the wires, keyboards, mice, everything. So it'd be great to have a little automated truck behind you, just following you to the venue.
I love that. Oh, you're muted, Avram.
Muted, Avram.
That would be very cool. I want to thank Ravi, our special guest, Ravi Butani. We really look forward to seeing where this project goes. Please follow him on YouTube and Twitter. And thanks, of course, to our audience. We are here every Tuesday at 2:30 p.m. Eastern, 7:30 p.m. British time. And we will see you next week. Bye, everyone.